Hey guys, it's Mrs. Cat, and I want to take some time to make sure that we are understanding all of the things we need to think about when we are drawing particle diagrams. So we're going to call this particle diagram considerations. We've talked about this stuff at different points, but I think it would be a good idea for us to kind of have all of these things in one place. So that's what we're going to be looking at. So I'm going to start with some of the first things we discussed with particle diagrams back in Unit 1. Um, and these are just going to be kind of things that anytime you draw a particle diagram, you just want to make sure that you're thinking about and that you are including in your diagram. So first thing I would say is that you're thinking about the type of particle. Um, so with this, we want to have different particles for different substances. Remember, you can represent those any way that you are able to. Different substances, right? Maybe you use different colors, right? Those are really close in color, aren't they? Let's go like this. Yeah. Maybe you use different shading, right? So maybe we shade one in, maybe we go lines through one. Okay. But you have to have different particles represented for different substances. When you do this, I want to make sure that you give me a key. So I know and you know what you're representing. Okay. Um, Aside from the type of particle, we want to keep track of the number of particles that we have. This is related to the law of conservation of mass, which is super important. I abbreviate this LCM, right? So if you see that on anything that you get back from me, that's what that means. Um, you have to keep track of these number of particles. Some of you are using like a crazy amount of particles. It's taking a long time for you to draw. It would take a long time for you to keep track of whether your particle number is the same before and after. It also takes me, honestly, a really, really long time to count and check for conservation of mass if you're using like 25 particles. So use a reasonable number. And then remember that the number of particles is related to the mass measurement. So that's going to be what you're looking at to help you figure out your number of particles. Okay, so mass was kind of our first big concept, aside from matter, that we looked at. The second big one was volume. Actually, let's do it this way. I'm looking at particulate first and then the macroscopic idea of this. So we want to look at the space between particles. And this is related to volume. Right? If we've got something that is taking up a small amount of space, those particles are going to be close together. If they're taking up a large amount of space, the particles are going to be further apart. Now, if we put the idea of mass and volume together, then we can look at density, but you can't look at just density without looking at mass and volume together. Okay, so space between particles, volume. Let's see, what was next? Speed of particles, which you have to show. We know that particles are moving. We're going to show this with whooshy lines, right? Slow, faster, and then fastest. Okay, more lines, more speed. Um, The speed of particles is related to temperature. Okay, all particles are going to be moving unless they're at absolute zero. Okay, 0 Kelvin or negative 273 degrees Celsius. So you have to show that particle movement. Okay, and that is determined based on the temperature. Okay, aside from speed of particles, while those particles are moving, they're going to run into one another, and we need to show those collisions of particles. These we show with those whammies. Which are going to be our collision lines with the container, right? So let me put a couple of particles in here. Okay, a whammy is gonna, whoop, I don't know what's going on with my pen here. Let's try this again. A whammy is gonna hit off of the container and bounce off, right? Hit and bounce off. Okay, then maybe our third particle is just hanging out, moving in there. Okay, make sure that your collision lines, your whammy lines make sense. Um, your particle is going to bounce and move off the side of the container. You're not going to have your little zigzag going towards the inside of the container. Um, these are related to pressure for a gas. Okay, so yes, there will be collisions of particles in solids and in liquids, but the measurement that you can make that relates to the number of collisions is based on pressure, which is only measured for a gas. Okay, so these things you kind of can tell, right? We talked about mass, we talked about amount of particles, we talked about volume, temperature, pressure. These are all the variables that we're looking at when we talk about the gas laws, right? So when you're drawing gas particle diagrams, you got to really think about all these things and show all of them appropriately. I would say there's one more thing that I would make sure that I'm considering, and I kind of already mentioned these, is to keep these simple. Okay, show what you need to, but don't show extra stuff. So, what do I mean by this? All right, this is super important enough that I'm going to highlight this. Right, so what do I mean by this? Okay, can you show what you need to with 4, 5, 6 particles? Okay, maybe even 3. If you can, great. There's no reason to use more. Okay, could you show the same thing using 15 or 20 particles? Absolutely. But it's going to take you more time to draw, to track, to interpret, and it's going to take me more time as well. Okay, so I'd rather us all be efficient with our use of time and keep things simple. Okay, use just enough to show what you need to and nothing more. Okay, so this is again, things that you should consider when you're drawing particle diagrams. If there are other things that we wind up needing to add to this list later on, we'll come back to this. But I would keep this in a place where you can refer back to it, especially as we get into more topics where we're going to be drawing particle diagrams. So let me know if you have any questions, and I hope to see even better particle diagrams moving forward. Thanks.